today is lesson 5 of our last unit on quadratic inequalities into two variables. It's our last lesson of the year. So let's just quickly review what we're going to be learning about and what we learned about last class. So last class, we talked about solving inequalities that have one variable. So it might have looked something like this. X squared plus 2x minus 8 is greater than 0. And we would express its solution as an interval of x values, such as x is less than -4 or x is greater than 2. So that's what we did last class. The difference between last class and this class is now we actually have an equation with two variables. And it's not an equation because there's no equal sign, but it's an inequality with a y and an x. So something like y is greater than x squared plus 2x minus 8. So notice the subtle difference there of instead of a 0, it is a y, which now means that the solution will be a shaded region of a graph. And the same as before, we represent a inequality with either a broken or solid line. So let's take a look at exactly what is meant by that and how we will do it. So if we had a question that said graph y is less than or equal, less than x squared minus 2x minus 3. If we were to graph it, there's a couple different steps that we could follow. So the first step is to find the x-intercepts of the graph. So you find that the exact same way that you would find a regular quadratic, and that's by factoring. So if I wanted to factor this, I would say, okay, what adds to -2 and multiplies to -3? Of course, my answer would be -3 and +1. So we could rewrite it like this. And what that tells us is that the x-intercepts are +3 and -1. So you flip the sign on the x-intercept at 3 and -1. So then the next step is to draw the boundary line of the function. So for this case, since it's less than, we get a broken line, whereas less than or equal to or greater than or equal to gets a solid line. So I'll start by drawing my coordinates or drawing my axes. Okay, then plot my points. In order to do that, I will plot my x-intercepts, one at -1, just approximating, and one at +3. And I also know my my y-intercept is -3 based off of my equation. So maybe something like that, and then I can connect the lines, but I'm going to be using a dotted line since it is less than or equal to. I still put the arrows on the top. Now I like this method because all you do is pick one test point. You either pick a test point inside or outside, because if you extend those lines, they just keep going and going and going. You have two options. It can either be inside or outside the parabola. So you pick one point on the line. I'm going to pick the point -4 and -10. But really, that point does not matter as long as it's either inside or outside. So, in the past, I've recommended using 0, 0. That would also work in this case. You go ahead and you sub that point into your equation. So my equation was y, which in this case is -10, is less than x squared -4 squared minus 2 times x minus 3. So at this point, you can either type it in your calculator or do some mental math, and you will get 16 plus 8 minus 3, which means that negative 10 is less than so we get negative 10 is less than 21, and this is a true statement. So is what that tells us is that that is a correct solution. So in this example, that means that we're shading. We're going to shade, and I'll use a highlighter. The outside of the curve would be our shaded area. So it would look something like this. And that would be our solution with a dotted line on the inside. Okay, and if it helps, just so you know exactly where to stop shading, you can, put lines in to show your box and then shade that outside version of it. Just to make sure you don't miss anything. Okay, so pretty straightforward. We graph the line. We use either dotted or solid line, depending on what kind of inequality it is. Then we pick a test point and we shade in the region. So let's do another example on the next page. It says graph the inequality, and thank goodness this time I get a graph so I don't need to wing it. Y is greater than or equal to negative 2x squared plus 8. Verify using a test point. So once again, my first step is going to be to factor this and see if I can find out the zeros. So I have, first thing I see is that I could factor out a negative 2. And I'm choosing negative 2 for a reason here. After I factor out a negative 2, I'm going to be left with a positive x squared minus 4. So in my brackets there, I actually have a difference of squares, so I can factor it one more time. I get negative 2, x minus 2, x plus 2. So remember, all I'm doing is factoring here. You have several different options for how you want to factor. You can use quadratic formula. You can graph, or you can use factoring. So any of those methods you can find the zeros with. Choose which method you like the best. So after I get this, I'm just going to rewrite my inequality. Y is greater than or equal to negative 2x minus 2 and x plus 2. So from there, I know where my zeros are, so I can go ahead and graph it. And in fact, for a question like this, if you had it on a test, you wouldn't even have to factor it if you didn't want to. You could just use your calculator to graph it. So I can now plot 3 points. I know my y, my x-intercept of negative 2, my x-intercept of positive 2, and my y-intercept of positive 8, and that comes from my c value here. So from there, I'm going to connect the points, and in this case, I'm going to use a solid line because I have greater than or equal to. All right, and now I pick a test point. I'm going to pick the point I mean, I can pick 0, 0, but let's try it. Let's do 0, 0 because I like that number. We get 0 is less than or equal to negative 2 times 0 squared plus 8. So our thing is 0 is greater than or equal to 8. That is not true, which means that that is not a correct test point, which means that we shade outside again. Okay, so I'm just going to go ahead and shade in everything outside of the parabola. Now, notice here that I'm not being super perfectionist or anything. Make sure that if you're, doing this on a test, that you try and maybe plot a couple more points on your graph to make sure this is exactly right. However, you don't have to be perfect. I think this is looking pretty good. Got it all shaded in. Beautiful. So any point outside of the curve, outside of the parabola, is going to be a solution to this inequality. All right. Oh, I guess we got a couple more examples yet. Okay, next one, determine whether each ordered pair is a solution of the quadratic inequality. So we're just checking to see if this point satisfies the equation. So I'm going to go ahead and I'm going to sub in my x coordinate for x and my y coordinate for y. And then just do some, calculator or mental math. I get 8 is greater than or equal to 3 times 9 minus 4. 8 is greater than or equal to 27 minus 4. 8 is greater than or equal to 23. Okay, so that means that this point is not a solution to the inequality. All right, next one. 12 is greater than or equal to 3 times negative 5 squared minus 4. 12 is greater than or equal to 3 times 25 minus 4. So 12 is greater than or equal to 71. So that is not a solution either. All right, we're running out of options. Let's hope this last one works here. 0 and 5. 5 is greater than or equal to 3 times 0 squared minus 4. So 5 is greater than or equal to negative 4. That is a solution. So the only ordered pair out of these options that were a solution is y is 0 and 5. Okay, example 4. Are the points on the graph y equals 4x squared minus 3x plus 7 part of the solution of the inequality y is greater than 4x squared minus 3x plus 7? So the way I think about this is if I were to graph my inequality, I would be using a dotted line. One that means that those points are not included. So the points on the original graph on the y equals our function would not be part of the inequality because it doesn't include those values. It's only greater than those values. So no. Because the inequality does not include those values. So as you're looking back through your notes to study, I'm just going to maybe make a note that this one's a dotted line, and maybe that'll jog your memory as to why it cannot be a solution. All right, example 5. Graph the inequality y is greater than x plus 2 squared. Write the coordinates of these 2 points that satisfy the inequality. Okay, so I'm going to start by plotting my zeros. However, when I see this, I see that I would get 2 zeros of -2, which means that it's just going to go down and touch the point -2 and then go back up. Also, when I expand, I'd get x squared plus 4x plus 4. So I know that it crosses up my y-intercept at 4 and then reflects, so 2 points away. Okay, I've got 3 points. I can now go ahead and graph it. It's opening up. The reason that I know that is it's got a positive a. Okay, so there's my parabola or my quadratic function. Then next thing that I'm going to do is I'm going to pick a point. My point, 0, 0. When I plug 0, 0 in, I get 0 is less than or equal to 0, sorry, is greater than 0 plus 2 squared. So I get 0 is greater than 4. Well, that is not true. So that means that the shaded portion of this graph is going to be inside the quadratic function. So I'd go ahead and shade that in, and then to fully answer the question, it asks for 2 points that satisfy, and I am going to pick, oh, and I just realized I made a mistake, because when I plotted the points, I didn't make it a dotted line here. I'm just going to go back in and make it a dotted line. Great, fix that. And then now I pick a couple points. Let's pick -2 and 2 and 0 and 6. So those 2 points satisfy the inequality. So of course we could go back and check that, make sure it actually satisfies, but because of our test point, we should be able to find, I'm just going to erase this x here because it looks like an actual x. All right, example 6, I'm going to let you do on your own. And then make sure you do that second part here that says write the coordinates of 2 points that satisfy the inequality. And let's work our way backwards. So I like these questions because it's a good review. You guys know you have your final exam coming up here in a couple weeks. And this is going to remind us how to write a quadratic function. So remember that all quadratic functions can be written in the form y equals a x minus p squared plus q. So there's a few things you need to know about that. A indicates the direction of the opening. P indicates a point on the vertex, and also how far it shifted right or left. And Q represents the other point of the vertex. So my vertex of this function here would be PQ. So if I look at example 7, it says determine the equations of the following inequalities. We know that my vertex is the point. Vertex is 0, negative, or positive 1. And that helps us create our equation. So we get y is equal to a, we don't know yet, x minus 0 squared plus 1. Okay, we need to now find out what a equals because we haven't figured that out yet. So I am going to plug in a point. I like this point right here. It is 2, 3. And I'm going to take that and I'm going to put it in for the 3 in for y. And I'm going to put the 2 in, oh, not for a. We don't know what a is yet. I'm going to put the 2 in for x. And I am going to solve for a. So I get 3 equals 4a plus 1. Subtract 1 from both sides and divide by 4. And I get a equals 1/2. Okay, now I can go back and write my inequality. So first off, it's going to be greater than or equal to. And then my function is 1 over 2 x squared plus 1. So a few things I noticed is that my opening was up, so it's a good thing my a is positive. Let's try it on the last one here. I'm going to do the same process. This one I see my vertex as -1 for my x value and positive 1 for my x value and 3 for my y. So I'm going to go ahead and put that. Y equals a times x minus 1 plus 3. Okay, then I am going to pick another point to solve for a. I'm going to pick the point 0, 4. Okay, so I get 4. Okay, that is not the point 0, 4. That is the point 4, 0. 4 for x, 0 for y. And then I put in 0 equals a times 4 minus 1 squared plus 3. Okay, spend a little bit of time solving. 4 minus 1 is 3. 3 squared is 9. 9a plus 3. Subtract 3 from both sides. And we get -3 equals 9a. Solve for a, it equals -1/3. Okay, I look, and now I think I have enough information. I'm going to be y is greater than -1/3 for my a value, x minus 1 squared plus 3. All right, so great way to end this lesson. We get to review how to make an equation for a quadratic function. That is it for the lesson. You guys can practice the questions below. Oops. Let's see here. Textbook, page 496, a few questions to do there before working on your unit review.